Hello everybody to the sounds of thunder in the background, which Dimitri is intensely relaxed about, as you can see. We commence this week's Easy 11 Plus live lesson, looking at some challenging maths logic problems, but not too many of them. How do you feel about that, Dimitri? He says he feels great. If you want to see more of Dimitri in videos especially for you, he is a frequent appearer in the videos that I send when people send me work for personal marking. And as you know, if you're a frequent viewer of this channel, you can send me a short piece of creative writing or comprehension or descriptive writing completely for free. Find out more in the link in the video description. And Dimitri is off. I'll also post a link in the comments under the video when we're done. Right, well, Dimitri's off, so I think we should get started. Just give me a second to let Dimitri out of the room. Off you go, Dima. Off you go. There you are. You can go now. Good. That's goodbye to Dimitri. And it's hello to all of you. Fantastic to have you again. Let's get cracking with today's lesson. Oh, and the rain is hammering down. It's truly wonderful. Might summer at last be over. Right, okay, so there are some really fiendish questions in this worksheet that I've sent you this time, including some fiendish grammar, and I hastily point out this is a question from somewhere else. I did not put that comma splice in after the word available. Thank you very much. So, jug questions. Now, jug questions are really interesting questions. Because, first of all, you have to get your head around a real-world situation and apply that on the page. You have to explain something which may be more intuitive to you, which is difficult. But also, these are the kinds of questions where there's a great risk that you will be floundering around trying lots of things and never get to the answer. Unless you think about it logically and think about where you're trying to get to and how you might be able to work back a little bit from that point. I can see more people joining the lesson. We haven't really started yet. I'm just sharing my general wisdom, and everyone's loving it. So you come in at the right time. Okay, so we've got two jugs available. One is 3 pints in volume, the other 5 pints in volume. You also have a tap, which can supply any amount of water. That's very generous of them, I think. If both jugs start empty, describe how to reasonably accurately, get 1 pint of water in one of the jugs. So there are things which you implicitly cannot do. For example, you cannot measure the side of the jug. Because, for instance, what happens if the jug is this shape? By, putting a ruler up the side, it won't tell you how much water is in it. We don't really know anything about these jugs. We just know their overall volume. And we're not told that they've got any measuring marks on the side or anything. This is a logic problem. It's not a thinking of a cheating shortcut problem. And if you come up with a cheating shortcut, such as read the sides of a jug, measure it with a ruler, get my other magic jug from the kitchen, which tells me how to measure, none of those things will work. You just have to use the stuff that you're told about. There are no shortcuts here. It's just about thinking through the problem. Right, the first thing you should always do with a question like this, in my opinion, is to sketch the jugs. Even if you think you know the answer, you're more likely to avoid mistakes if you have an image of them in front of you. Now, by an image, I just mean something like this. So this is the first jug, 3 pints. And I'm going to call this, and this is actually going to help me a lot, jug A, okay? And now we've got another jug, which is bigger. I don't need to measure them, it's just a sketch for my own benefit and for the benefit of the person following my explanation, as you will see. And this is 5 pints, and this is jug B. Now, nowhere in the question do they tell us that these are jug A and jug B, but now that I've called them that, I don't need to keep saying the smaller jug, the larger jug, the larger jug, the smaller jug when I explain. I can just refer to A and B, and that's going to make life a lot easier for me. Now, if you have no idea what to do with a question like this, it's very sensible to start just by trying things out. So, for example, you might try something like fill jug A, but you don't want to take up all the answer space with this. So you might say, well, say B, fill B, pour into A, and so on. But I'm going to pretend that you've already done that. You've already thought about it. And we're getting to the point where you've got a sense of how it all works, but now you want to think logically about how you might get to the answer. I wonder what's going on in the comments. Rook says, Dimitri sees a rare Grigri. They look at each other, a face-off for the most cunning. Grigri messes up the kitchen table and flees just as Ms. Robert arrives. The poor Dimitri is framed. Sorry, I shouldn't get distracted from doing the maths, but I love this because it so accurately describes the kind of interactions that do in fact go on in this household. So well done, Mr. Rook, or Mrs. Rook, or Miss Rook, or Ms. Rook, or whatever you are. Master Rook, perhaps. Okay, so, oh dear, the screen is starting to peel off my tablet. I'm going to need to get a new one. That's going to cost me. Right, so we got these jugs. Now we're going to think about it logically. What are we aiming for? We're aiming to get 1 pint of water. Now, what do I notice about 1 pint of water? Well, I notice that the bigger jug is 5 pints. So if I could get rid of 4 pints from it, I'd have 1, but it isn't obvious how to do that. The smaller jug is 3 pints. So I could get rid of 2 pints from that and I'd have 1 pint, but how do I do that again? But the difference between 5 and 6 is 1 pint. And 2 lots of the small jug would make 6 pints. So if I had 2 small jugs and I tipped 1 completely into jug B, and then I got my second one and I tipped it into jug B until I couldn't tip any more, I would have a pint left. So how can I replicate that? Well, I can have 2 small jugs because I've got a tap with infinite water. A tap which can supply any amount of water. So actually I could just fill jug A twice. And suddenly I have a possible way to do it. So we're going to... I've got cat fur on my screen. We're going to work with really clear but simple instructions. So fill A and pour into B. Okay? Simple. We don't need to write stuff like taking care not to spill any on the way. That's implied. Okay? And then I'm going to take a note of what the situation now is, because for more complex questions such as B, this is going to be essential. So I'm going to write A, 0, because I poured it out, B, 3. Okay? In fact, I'll write it as fractions. 0 out of 3, 3 out of 5. So that means I've got no pints out of a possible 3 pints in jug A, and I've got 3 pints out of a possible 5 pints in jug B. Okay? Now I'm going to fill A again. Fill A and pour into B until full. That's important because I'm not going to keep pouring after I fill B and spill the excess on the table. So now A is going to have, well, what's B going to have? B is now going to be full. It's going to have 5 out of 5 pints in it. But I've only poured 2 pints from jug A because that holds 3 and I've only poured 2 across. So now A contains 1 out of 3 pints. And that's what I want. I want 1 pint in one of the jugs. So I've got there. So I got this quite easily by thinking through, what am I aiming for? I'm aiming for 1 left. It's basically a subtraction. Okay? So I could do 6 minus 5. That would give me 1. How can I achieve that with my 2 lots of 3? And that's how I got there. Just to make it absolutely clear, I'm going to write 1 pint remains in A. Okay? That's it. It's actually fairly straightforward. Armel says, what if you did B minus A equals 2 and then do A equals 2? How does that still work? I don't know how you do A minus 2. How do I take 2 pints out of A without measuring 2 pints? The whole point is we can't measure. We can only work with the difference between these 2 jugs. So I don't quite see how that would work. But if I'm missing something, let me know. If you come up with a better solution or a good alternative that doesn't take more steps, why not let me know in the comments under the video. I won't be able to work them all out in the live comments, although feel free to put them there. But after the lesson, you can write comments under the video. And if you've got better solutions, I'll be interested to see them. I can't promise to check every single comment thrown out. Do check that they work before you write them there, because I don't have time to work out loads and say, no, that one doesn't work. Okay, now this is where the real magic starts. So we've done A, which is kind of training you. And now we have the answer where it gets a little bit more complicated. So what have we got here? We've got the same 2 jugs. So let's sketch them again. We got more cat fur on the screen. We got 3 pints, and we're going to call that A. We got 5 pints, we're going to call that B. And we got 8 pints, which starts full, so that's how I'm showing that, that's 8 pints, and I'm going to call that C, very imaginatively. I'm also going to remember 8 to look a little bit more. No, I'm going to rub that out and start again, because we want that to be clear, don't we? Otherwise we won't understand what's going on. Okay, 3 pints, 5 pints, and 8 pints. Now, we learnt a lot from the first question about how we think about a problem like this. So, we don't want to spill water, obviously. Well, we don't want to spill water, okay, so we can't chuck any away. That's important. We can't use any extras. All we got are these 8 pints. And we need 4 pints in at least one of the jugs, okay? So one or more jugs needs to contain 4 pints. Now, I've worked out a way of doing it. If you can find a way of doing it which is more efficient, I'll be very keen to know. There's often more than one way of doing these things. Right. So let's think about what we did with the first one. We want 4 pints, okay? So, sometimes you get more complex endings. But what about if it's relatively simple? Let's ask ourselves that first. In fact, I'm just going to check my notes so that I don't do something monstrously complicated. Okay, so let's say that we had a certain amount and we could tip some of it into jug A, which is 3 pints. How much would we need to have in the other jug to have 4 pints left? We'd need 7 pints, wouldn't we? If we had 7 pints and we tipped what we could into A, which is 3 pints, we'd have 4 left. So if we end up with a jug with 7 pints, that would be really good, as long as A is empty. What about with B? B is 5 pints. So if you had a jug with 9 pints in, and we tipped out 5, we'd be left with 4. But none of these jugs can take 9 pints. So it would be a really, really good outcome if we ended up with 7 pints in one of these jugs, which has to be C, because it's the only one that can take 7 pints. So if we can get 7 pints in C, that would be the last step before solving the problem, because then we just need to tip 3 into A, and then we got 4 left in C. Okay, can you see the logic there? We're saying, what can we tip 3 pints or 5 pints out of to be left with 4? 7. Okay, if we tip 3 pints out of 7, we're there. Now we got 8 pints in total. So if we have 8 pints in C, there must be 1 pint somewhere else. Okay? And because we need to tip all 3 into A, that means that we want 1 pint in B. So we want 7 pints in C and 1 pint in B, and then we tipped 4 of those, we get 3 of those 7 pints into A, and there were 4 left in C. You following me? I hope you are. But don't worry, because we're going to set it out all in stages when we explain it. Okay, now that basically means we need to get 1 pint in A or B. How do we do that? And this is where you need to think intelligently about the whole question. Because what have we just done? We've just explained how to get 1 pint in A. And we can easily turn that into 1 pint in B if B is empty, and we just tip it across. So the first thing we want to do is copy out our working for part A, so that we got 1 pint in A. But we can't just copy it, because we can't just say fill A, because we don't have a tap. We have to pour it from C. So the first step is going to be C to A until full. Okay, we don't need to say until A is full, because that's obvious. Okay, C to A until full. That's completely clear. And now let's note what we've got. So A is 3, it's got 3 pints in out of a capacity of 3. B has no pints in out of a capacity of 5. And C, and these notes are going to be important because otherwise we're liable to lose track. C, we poured out 3 into A, so C has got 5 in it out of a capacity of 8. Okay? And then remember what we did for part A. We need to tip those ones from A into B. So A to B. It's not until full because B is a capacity of 5. So A to B. So A now has none out of its 3 pint capacity. B has 3 out of its 5 pint capacity. And C still has 5 out of its 8 pint capacity. Okay? And we need to do it again. We're just copying A. So we need to fill A again and then pour 2 of those pints into B until B is full. So now we again do C to A, until full. Okay, so now A is full again, 3 out of 3. B, we haven't done anything to B. And C, we've tipped out another 3. So C has got 2 out of 8 now. We've tipped 6 pints out of C in total so far. And then we do A to B until full. Okay, we're just doing what we did for part A. So now A has our magic 1 pint in because we've been able to tip 2 into B because there are only 2 pints left there. B is now full. And C, we haven't touched for this one. 2 pints out of the 8 possibilities. Okay, now go back to where we started. Hello to Joyce Oyebeko, who says, I am new. It's wonderful to see you. This is a very tricky question that you started with, so good luck with it. But well done for being here and well done for sticking with the question. Okay, so we said that we wanted 1 pint in B and 7 pints in C. So how can we get 1 pint in B? Well, first of all, we need to empty it. That means we need to tip from B back into C. Okay? So now we have B to C. So now we have A is 1 pint out of 3, B is no pints out of 5, and C is 7 pints, remember we wanted 7 pints, out of a potential 8. We need to tip C into A, so A needs to be empty, so now we need to transfer A to B. So A has got no pints out of a potential 3, B has 1 pint out of a potential 5, we're not really very worried about that anymore, and C still has 7 pints out of 8. And this is where we wanted to be, ladies and gentlemen. We wanted 7 in C and 1 in B, because now if we pour as much as we can of those 7 pints into A, that'll be 3 pints, we'll be left with 4 in C, which is what the question wants us to get. 4 pints in at least one of the jugs. In other words, 4 pints in a jug. That's going to be C. So now, last step here, we are going to say C to A until full. I'm just squishing it a bit at the bottom of the screen. So now we have A is 3 out of 3, B is 1 pint out of 5, and C, drum roll, we've tipped out 3 pints into A, so there are 4 pints left. So now I'm just going to finish off by saying in the very slim space here, there are 4 pints in C. Okay, so for the handwriting, you know what it's like if you're regular viewers. And there we have it. So we got there by thinking back. We thought, well, 7 minus 3 would give us 4 pints. So if C had 7 pints in, we could tip 3 of them into A. Okay, so we want 7 pints in C and the other one out of the way in B. The other one. So in other words, with 8 pints, this is really about how do we get 1 pint by itself, because that will leave us with what we need. And we found that in part A. So we've used the information from part A. And then once we've done that, it was just a matter of adding a little finishing stage. And this is a really important thing, that very often when you've got 2-part questions or 3-part questions or whatever, multi-part questions like this, rather than working from scratch, they are often set up so that you can use some of the information from an earlier part of the question to answer a later part. Okay? Question setters are often smart like that. Some of them, not very many. Okay, Basma says it's buffering for them. Please don't write it a million times. If it's buffering, it's very likely to be because you have the quality set too high on your YouTube video. I know that my videos are always of the highest quality, so it's an understandable problem, understandable mistake to make. Just go to the cogwheel, bottom right, click on that, and just turn down the quality a bit, and I think you'll find that your problem is likely to go away, because it's most likely that the buffering is at your end, because my internet is insanely fast and capacious. Like the brain of Sarah Gebre Myram in the comments, which is also very fast and capacious. Right, something totally different, and I think rather marvellous, and it was a very good opportunity for me to do some revision on the binary system. Now I'm going to tell you now, if you're coming to this fresh and you haven't looked at the worksheet in advance, there's going to be a lot for you to absorb here. And I'm slightly assuming that you've read this already. No fault, no blame attaches to you if you haven't, but this is a really good reason to get to look at the worksheet before the lesson. I send the worksheets out by by email, normally a few days in advance, normally on a Saturday morning, although it was a little later this time. If you want to get those worksheets in advance, then the best way to do it is to join my mailing list. Look at the free papers and videos link in the video description, down here on YouTube, up here on Facebook. Okay, right, so this wonderful binary question, it's one of these questions where once you really understand what's going on, it's actually not particularly difficult, I think. But the understanding what's going on, if you've never encountered this before, which you probably haven't, is quite a brain exercise, I think. I've added a little bit of clarification. In my opinion, the question wasn't clear enough. I thought it was confusingly written. So those things in red are me just adding a bit of extra explanation. So you know about the decimal number system. 149 is 100, 100, 4 tens, and 9 ones. Okay? So what they're saying here is that the number 149 is, let's work backwards through these. So it's 1, 1, okay? And they say that each column is 2 times the number before. So pay attention to this bit. This bit is really, really important if you're going to understand this question. So 149 is 1, 1, no 2s, 1, 4, no 8s, we're doubling each time, 1, 16, no 32s, no 64s, and 1, 128. And then we just add them together. So we add together 1 and 4, which is 5, and 16 gives us 19. What? No, 21, sorry. And 128, and we get to 149. So that's how it works. The right-hand column is units. Each column to the left of that doubles the value of that column, and you can either have one of the thing or none of the thing. Okay? The only allowable binary digits are 1 and 0. Now, binary is really important because it's at the heart of how computers work, because computers are gazillions of on and off switches. So off is 0 and 1 is on. And so a computer can run, and the internet can run and everything, by basically passing information around as loads of on and off instructions, noughts and ones. And so this binary system going units, 2s, 4s, 8s, 16s and so on is the way that our digital technology uses to pass information. That's why it's digital. It's the digits 0 and 1. Okay? So that's why this question, which may seem weird, is actually incredibly relevant to everything that's happening right now with me doing this live stream and you watching it. People who don't get binary, don't worry. I mean, I don't think you're going to get it just if you haven't looked at the worksheet already and thought about it, or even looked it up online. I don't think you're going to get it just by watching this. You'll get it by watching this and going back to the worksheet, thinking about it, maybe doing a little bit of research and then coming back through. But it's well worth getting to grips with, because it's really more important to our daily lives than decimal numbers are, I would say, really, in many ways. You use a computer a lot more than you use money, for instance. Right, now into actually applying it. How would the binary number 1000 be written in decimals? How did I lay this out? Oh yeah, nice and simple. Okay, so 1000. So we got units at the end. In other words, number of ones, number of twos, number of fours, and the number of eights, because we keep doubling from the right. So we got no units, no twos, no fours, and 1 8. So what is this number? 1 8. What might that be? I think it might be 8. This is another of these questions where setting it out clearly is one of the most useful things you can do. The simple way that I set it out there made it quite easy to understand, I hope. How would the binary number 101010 be written in decimal? Okay, make sure you got it the right way around. Don't try and do that decimal to binary. It would be rather a big number. How would it be written in decimal? So it's the same thing. So let's write it out again. 101010. So we got no units. We got 1 2. We got no 4s. We got 1 8. We got no 16s. We got 1 32. So we got 132 and 1 8 is 40 and 1 is 41. Okay? Dead easy. Just a matter of adding up those numbers. I suppose for full working we could write 32 plus 8 plus 1 equals 41. Okay. So this method, I left that a little bit cramped, so that's an argument for maybe allowing even more space for your working than I did there. That didn't quite work out, but I hope you understood. Right, and now we are reversing it. Always read the question carefully. How would the decimal number 13 be written in binary? Okay, so we need to break it down into 1s, 2s, 4s, 8s, 16s, and so on. So we start with the biggest of them. 13 equals, well, it doesn't have any 16s in it, but it does have an 8. Okay. Does it have a 4? 8 plus 4 is 12. So yes, you can get a 4 into that. So 8 plus 4 is 12. What do we need to make 13 plus 1? So we are going to need, so let's set this out again for now. Units, 2s, 4s, and 8s. We don't need to go further than that. Units, we got 1 unit. We got no 2s. We got 1 4, and we got 1 8. So the answer is 1101. So the number 13 in binary is 1101. And there are lots of binary converters online where you can put in a binary number and find out what it is in decimal, or put a decimal number in and find out what it is in binary. So if you don't believe me, you can go and check. How would the decimal number 31 be written in binary? Okay, same process. It goes 1, 4, 8, 16, 32, 64, and so on. So what's the biggest one of those that might go into 31? Well, 32 won't, but 16 will. So it includes a 16. Okay, we can't have more than one of any of these because we can only have noughts and ones, don't forget. Includes a 16. It's going to include an 8 as well. 16 plus 8 is 24. Can we get a 4 in? Yup. Takes us to 28. Can we get a 2 in? Yup, takes us to 30. And a 1 takes us to 31. Okay? So we got 1 unit, 1 2, 1 4, 1 8, and 1 16. Okay, so we got 1 unit, 1 2, 1 4, 1 8, and 1 16. None of these are zeros. Okay? 1 1 1 1 1. Simple. Ish. Okay, we're actually nearly there with this question now. What is the largest decimal number that can be represented with 8 binary digits? So let's ignore the word decimal. What's the largest number you can do with 8 binary digits? Well, binary digits can be either 0 or 1. So therefore the largest number with 8 binary digits is going to be 8 ones, right? So let's write that out. So we're going to write it as 1, 1, 1. I'm really spreading it out. 1. I've learned my lesson. 1, 1, 1. Okay, 8 ones, 8 binary digits. We're in binary, so what are these? We've got units, 2s, 4s, 8s, 16s, 32s, 64s, and 128s. We're doubling each time. Okay? So we got one of each of these things. So basically, we just need to add them together and find out what the number is. That's it. Okay? Actually, quite simple. So we need to do 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2, and 1 unit is 1. Okay? We just need to work that out. I told you that once you understand it, the actual maths is not very difficult here. It's all about getting the clear picture in your head of what's going on. So, easiest way to add these up, I wouldn't do one massive column. Instead, I would chunk it. So, what's 128 plus 64? Well, 128 plus 60 is 188 plus 4 is 192. Okay, fairly straightforward. 32 plus 16, 32 plus 6 is 38, plus 10, 48. Plus 8 plus 4 is 12, plus 2 plus 1 is 3. Okay, what's 192 plus 48? Well, 192 plus 8 is 200, so 240. 240 plus 15 equals 255. So the largest decimal number with 8 binary digits is going to be 8 ones, because binary digits are only 0 or 1. We find out what each of those place values represents, and then we add them up. And it's actually relatively straightforward. This is one of the few lessons I've had where I'm actually losing viewers as it goes on. I think there are people who are just a bit overwhelmed by it. That's understandable, but not advisable, because how to work through a question like this is a really important exam skill, because most of your exam, yes, will test you on your knowledge of maths. But parts of the exam towards the end will often give you new knowledge like this and see how you can deal with it. You're not expected to know binary for 11 plus. I would say that probably one candidate in 1,000 would know this stuff in advance. What they're testing is your ability to see the question, understand the explanation, and then work through it. And getting used to doing that is so important. So even if you're leaving now, do come back, go at the worksheet, come back, follow it through again, and work out how I'm approaching this question. It's not so much about knowing binary, it's about seeing how I approach a question on something weird and unfamiliar. Right, last part of the question. Describe a way to multiply a binary number by 2 without converting it to decimal first. So, the thing here is, there's actually a way that you can work out just by logic, just by thinking about it. But most people are not just going to see it straight away. So what most people are going to need to do is play around a little bit, okay? Try some things until they start to see a pattern. So what we want to do is just try multiplying some binary numbers by 2 until we start to see something falling out. We want some nice simple numbers, but with enough for us to draw conclusions from. So let's try some binary numbers. I'm going to label column B for binary and D for decimal. Okay, so let's try 1, 1. That's a nice simple one to work with. Okay, and let's multiply it by 2. That's a decimal column. Equals, and we'll say what it is in decimal, and then we'll say what it is in binary. That seems like a good workflow for me. Okay, so that's not 11, it's binary, so it's 1 unit and 1 2, so it's 3. 3 times 2 is 6. In binary, 6 is, well, it's 4 and 2 and nothing extra. So it's no units, 1 2 and 1 4. So it's 1 1 0. Okay, so it's 1 1 with a 0 at the end. So already you should be asking yourself, is that a pattern? The adding a 0 at the end, or is something else going on? Let's try another one. What about 1 0? Okay, there's no reason I've chosen 1 0 except that it's another fairly simple binary number. 1 0 times 2. Okay, so what's 1 0? It's no units and 1 2. So it's a 2 times up by 2, we get 4. What's 4? It's no units, no 2s, and 1 4. So again, there's a 0 on the end. Now I want to take a slightly more complex binary number and see whether it still holds true. Let's not go crazy. Let's try 1 1 1. 1 1 1 times 2. What's 1 1 1? It's 1 unit, 1 2, and 1 4. So it's 4, 5, 6, 7. 7 times 2 is 14. How do we get 14 in binary? Well, there's no 16s, but there's an 8. There's a 4 that gets us to 12, and there's a 2, and that gets us there, so there's no 1. So it's going to be 8, 4, 2, and no units. 1 1 1 0. So again, we've got this with a 0 on the end. Here we had this with a 0 on the end. Here we had this with a 0 on the end. So there's a very, very clear pattern now. You add a 0 on the end. We have not proved that to be true through what we've done here. It could be coincidence from these 3 examples. But in an exam situation, I think you've got enough evidence to answer quite confidently and move on to the next question. And take the risk that you've been unlucky by just choosing examples that happen to add a 0. So, add a 0 on the end. Okay? That's all we need. Right. Now, I said that it's possible to work out that this is the answer without actually doing all the messing around. Let's think about this. What happens if you add a 0 on the end of a decimal number? So this is not my working out, this is just me showing you stuff. If I add a 0 on the end of a decimal number, so let's say my decimal number is 34. What happens if I add a 0 on the end? I've times it by 10. If my number is 27, if I add a 0 on the end, I've times it by 10, 270. Adding a 0 on the end of a decimal number multiplies it by 10. Now, why does it do that? Well, what's happening is that I'm shifting everything else one place value to the left. So in the number 34, oh, my rubbing out is not working, great. Okay, in the number 34, it'll probably happen sort of later. Oh, my screen's frozen again. I love it when this happens. Not. Oh, for heaven's sakes. Oh, and we're free. Good, excellent. That's normally the way it goes. Right, in the number, this because my laptop's getting hot. In the number 34, we have 4 units and 3 tens. If I add a 0, I'm pushing it to the left. I now have 4 tens and 3 hundreds. Same happens down here. 27, 7 units and 2 tens. Put a 0 on the end, now it's 7 tens and 2 hundreds. So the 0 pushes all the place values 1 point to the left. Now what's happening, and by the way, that multiplies it by 10 because we're on a decimal. So a system based on tens, that's what decimal means. Now with binary, so I got 11, and I've got not 11, I got 1 1, 1 1, 1 unit, 1 2, and I add a 0 on the end, I'm pushing every place value to the left by 1 point. Every number 1 point to the left along the plate, whatever. I probably got that backwards, it doesn't matter, you know what I mean. Just as in decimal, each place value is 10 more than the last, ones, tens, 100s. With binary, each place is double the previous one. So if we push it one lot to the left, we're doubling. So in other words, the way to multiply a binary number by 2 is to shift everything one place to the left by adding a 0 on the end. You can't add a 1 on the end because that shifts everything one place to the left and adds 1 unit. You've got to put a 0 on the end, which shifts everything one place to the left without adding any units. Just as you multiply a decimal number, a normal number, by 10 by putting a 0 on the end, which shifts everything one place to the left without adding any units. It's exactly the same principle. So multiplying in binary by 2 is just the same as multiplying in decimal by 10. Now, if you understood all that, wow. If, more probably, you didn't understand all of it, go away, spend some time with the worksheet, and then come back later. The last question is a bit of... So what just happened there, ladies and gentlemen, is that a cat knocked over the laundry drying rack and it just crashed into the door of my study. That is my life. Right, the next question is a little bit like Naughty Cats. A bit of fun. This will not take nearly as long. I think it's just an interesting problem. This is one that I came up with, actually. Well, no, that's not entirely true. It's based on a really common logic problem, and I came up with this version of it for one of my 11 plus Lifeline maths papers. I didn't come up with the whole concept from scratch. So you've got 2 pieces of string and a box of matches. Each piece of string will take exactly 20 minutes to burn from one end to the other. Oh great, so I can time it by saying when it's burnt halfway down, that's 10 minutes. When it's burnt 3/4 of the way down, that's 15 minutes. When it's burnt 18/20 of the way down, 9/10 of the way down, that's 18 minutes. No, you can't. It doesn't burn at a steady rate. So it might burn the first half of the string in 1 minute and the second half of the string in 19 minutes, for example. We got no idea. And in fact, you wouldn't expect a string to burn at a completely steady rate because it's going to be more densely wound at some points. It might have contamination at some points. All kinds of factors can play a role. The wind on it might be different at certain points as it's blowing, as it's drying, whatever. No, actually, I don't like that one because that would change the overall rate. Ignore the wind thing. Yeah, a string not burning evenly is a normal situation. But we don't know how unevenly. It will take exactly 20 minutes to burn from one end to the other. So we only know one thing, really, which is that if you light the string at one end, by the time it's burnt to the other end, 20 minutes will have elapsed. Okay, so we can find 20 minutes. We've got 2 bits of string, so we could find 40 minutes. But we need to measure 15 minutes. And now you'll be thinking all kinds of clever things. So for example, maybe you fold the string in 2. But then the string doesn't burn at a steady rate. So if I fold it in 2 and light one end of the folded string, then one side of the folded bit might burn faster than the other. Is it when that's go, when I get that? Yeah. I mean, that doesn't really help me. Do I fold it in 2, then mark the point, then light one end? No, because as I said, one end might burn for 1 minute and the other end for 19 minutes. So that doesn't tell us either. So folding is not going to help. What else can I do this? I've got to be able to find less than 20 minutes. So we're playing around with our bit of string. And when we're playing around in maths, we should draw it. So I'm just going to put a key to help me here because this might form part of my working out. Okay, so the cross is going to be a burning point. Might be where I light it. It'll be at the start, that's where I light it, but it's also the point that's burning. Okay, sorry, my handwriting's awful. That says burning point, honestly. Oh, never mind. That's like something different. Oh, never mind. Burning point. It says burning point, all right, people. Okay, so if I light it at one end, I've got 2 bits of string, haven't I? If I light it at one end, it's going to take 20 minutes to burn out. And this is why I just play around a bit. What if I light it at both ends? So I light it at both ends. It burns unsteadily. But wherever those burning points meet, it's going to be half of 20 minutes, isn't it? Because if it burns faster from this end and burns more slowly from that end, still, let's look at it this way. If you take each bit of the string and add them all together, they together take 20 minutes to burn. So if this end burns slowly but that end burns fast, still when they meet, 20 minutes of string will have burnt, but it will have burnt from both ends. So that will take 10 minutes. It's a little bit like one of those things where I should have put an example for this, should I thought about it. Like when you have to find the centre of balance of an object. So you put your finger at each end, you can see there, and you push your fingers towards each other, slowly, 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 until they meet. And that's the centre of balance of the object. It's twisted a bit, that doesn't help. You see it's just, on my phone, it's just off centre, there, which tells you something about where the battery is in my phone, okay? Extremely snazzy, basic Samsung phone. So it's a little bit like that principle. So if we light from both ends, we can get 10 minutes. Okay. But how does that help us? We want 15 minutes. How would we get 5 minutes? How would we do that? Because we want 15. We want 10 and another 5. What happens if you light both ends of one piece of string and then both ends of the other when it finishes? Now then we got 2 10s, that's 20. What happens if we light both ends of both pieces of string at the same time? They'll finish at the same time, that's 10. So we're playing around, trying things. We can be fairly sure it's going to be to do with lighting both ends. What happens if at the start we light both ends of one piece of string and one end of the other? Well, we know that the first string will have burnt up after 10 minutes. Okay, so after 10 minutes, the first string, so first string finishes at exactly 10 minutes. Okay, we've worked that out already. We're just playing around seeing what happens. What's the situation with the second string? Well, the second string, so we lit it over here, but half the time is burnt out. Not necessarily half the length, but half the time. The second string is still burning. It's burning there. And it's got 10 minutes left. Second has 10 mins left. When our first string had 20 minutes left, if we lit it at both ends, it burnt out in 10. Our second string has got 10 minutes left. What happens if immediately when the first string finishes, we then light the second string at the other end? Light it at other end now has 5 mins left. Sorry, it's behind my head there. Now it has 5 minutes left. 15 mins. Second string finishes. Now, if you already knew the answer, you could actually write this more succinctly. You could say something as simple as light one string from both ends and the other string from one end at the same time. Immediately when the first string finishes, light the other end of the second string. When that finishes, 15 minutes will have elapsed. So you can explain this really simply in 3 sentences, if you already know how it's done. But what I've shown you here is a way to explain it while working through the problem, which I think knocks off 2 birds with 1 stone. Harley explains it beautifully. Thank you very much. Someone said cut it. Cut it doesn't answer the question. Someone said, while that could be in real life, this is a maths question and asking for that, they want a well-thought-out answer and not just cut it. Well, thank you. I mean, it's a very sensible intervention, but actually it's not just that. Cutting it will not get you the answer, even in real life, because, as I explained earlier, your typical piece of string will not burn at a steady rate. This is not just a made-up thing, it's a statement of reality. String, it's wound a bit more densely in some places, a bit more loosely in others. It might have contaminants in it from places it's been resting on and whatnot, from the winding process, whatever. It might be squashed more tightly in some places. So a piece of string will not burn steadily. So if you've got a piece of string that takes 20 minutes to burn, if you chop it in half, it's very likely, in fact it's a virtual certainty, that one half will burn a bit faster than the other. So you do not know that each half will burn in 10 minutes. And you certainly don't know that each half of that will burn in 5. So cut it, it's not just because of the way the question's set up, cut it really isn't an answer to this question. If your pieces of string were fuses made for a demolitions expert, then cutting it would get you very close, because you've got very, very carefully calibrated burning string which is designed to burn in a very controlled and reliable fashion. But that's not what we're talking about. We're just talking about 2 random bits of string here. All we know is the burning time overall. So yeah, I think it's quite an interesting question. And we're on to today's So I thought I would just briefly talk a little bit more about one of the ideas that we've been developing in today's lesson, just stepping back a little bit. Because you'll see that with some of these questions, we've had to try things out before we got into it. The binary one, once we worked out how it worked, we could just go in and answer the question, at least for all of it apart from part D. But for most of it, we've been trying things out. Let's just pop back in a second. So with this one here, we started just by thinking, what happens if I do this? What happens if I do this? What happens if I do this? With part with part D of the binary question, we started out just by trying some numbers. And with this here, we started out by just messing around a bit and saying, well, what happens if we pour this into this? Oh, we're taking away a bit. And then we kind of got into it. But look at part B of the first question. Yes, we tried some stuff out. But if I just kept trying stuff out, I don't think I'd have got to the answer there. I think I'd have still been trying to get the answer there and there and there. And there'd just be pages of pouring to and fro. And in the end, what would happen is I keep ending back where I started probably. And it would be very frustrating and I might never get to the answer. And I certainly would be unlikely to in the exam time. So I'm very keen on trying stuff out. But what I want to talk about in this tip of the week is that you need to try stuff out, but ideally not indefinitely. What you're aiming to do is try stuff out enough that you start to get some logical hooks on the question. So for example, looking at part B here, it's about trying things out until you've thought, hang on, what I'm doing at every stage is taking away. When I pour into another jug, I'm taking water away from the jug that I have. So I could, for example, take away 5 pints by pouring into B. And if I wanted 4 left over, I'd need 9. But none of these jugs can hold 9 pints. Or I could take away 3 pints by pouring into A. So if I wanted 4 pints left, I'd need to start with 7. Jug C can hold 7 pints. Okay, there are 8 pints in total. That means I need 1 pint somewhere else. I worked out how to get 1 pint in A, and you see what I mean? So I've messed around a bit, I've tried stuff, but then once I've tried stuff enough and I understand the logic, I then step back and think about it logically. I think back from where I want to get to and I work out a route that might take me there. So what I'm trying to encourage in this tip of the week, jumping back to my full and glorious face again, is that trying stuff out with a confusing question is a very good way to start. But try not to just keep trying out indefinitely unless you have no other option, and then it's the best way to go. Try to try things out until you've got a glimmer of logic, such as, oh look, oops, I'm on the wrong question. Such as, oh look, when I times by 2, they always get a 0 on the end. And then see what you can do with that. See whether you can actually work out what's going on. Oh yeah, sorry, I was going to show you the screen. That's it, there was one with 0 on the end. Yeah. So try things out, be a bit chaotic, throw ideas onto the page, but don't wait too long to step back and think about it. Okay, we've been going on a long time with this one actually. I thought it would be shorter because there weren't many questions. So let's just take a few of your questions, just 1 or 2 of them, and then we'll knock off for today. So, Ahmed Mukhtar Art, why are you here then? Okay, I'm not going to deal with that one. Some of us did our 11 plus today, Robert. Well done for getting it done. I cannot believe that you're watching this lesson now in that case. Many congratulations on getting underway with your 11 plus if this was your first one. Which grammar schools do I recommend? I mean, the country has, hundreds of good grammar schools. It will be a meaningless answer, I'm afraid. And it depends where you live, obviously. Apparently someone's being rude to me. I can't see it. I don't know. I'm sure my life will go on. What to do last minute except revise? Well, revision means going over knowledge you already know, but also practice. But don't just practice just by ploughing through whole papers of time limits all the time. Find questions focused on the things that you still find a bit tricky and practice those questions. Take them out of papers you haven't done yet. Also, this is a really useful thing that people don't do nearly enough. Go back to old papers that you've done and try them again. That can be really good for learning because then you vaguely remember what you did before, though not quite. And that inspires you. And then you mix that with the new ideas from the practice you've done since. And together these can come together for a really powerful learning experience. And then you can compare to your new answers to your old answers. And there's a whole lot to get out of it. So I'd strongly encourage going back to old papers that you did some time ago in the past. That's a useful one for the last minute revision. Should I get a cat? Only if you can look after it properly and lovingly and give it your full attention. Those things being the case, having a cat is wonderful. It also depends on the cat. So we got Dimitri and then we realised that he was pretty lonely and bored and then we had to get Grigri as well. So if you get one of an animal, don't do it unless you could keep two of the animal, I think would be my advice, because you may find out that you need to get a second. And if you get one cat and you can only keep one cat and they're lonely, then what do? So with most kinds of animal, my advice, don't get one unless you know that you could look after two if you had to. Can you do GL? I've done absolutely loads on the GL. Have a look for my videos. Congratulations to Ahmed or Ahmed on passing their 11 plus. Fantastic. Okay. We're not super abundant with questions today, so I think I'm going to knock off at this point. I'm exhausted, I've got to tell you. I'm absolutely shattered. That was real brain work for me, actually, explaining that. I hope I did a reasonable job. I know it was difficult. Yeah. Well, look, if I was smarter than I was, I wouldn't be able to relate to you so well. So it's a good thing that takes me a lot of mental effort. Right, fantastic to have you here. Once again, for anybody who hasn't heard yet, I mark your work for free. If you haven't sent me something for marking before, you can send me a short piece of creative or descriptive writing or short essay or short letter or whatever, up to 300 words. You just need to email it to me. There's a link about it in the video description. I'm going to post one in the comments, and I send you your feedback in a beautiful online file with little videos of me and little voice clips where I explain exactly what you're doing brilliantly and what you can do better. So take advantage of that. Give it a try. You might like it. I do it as a promotional thing so that people get to see my marking service. It's for anybody who hasn't sent me a piece of work for me to look at before, basically. Simple as that. Yeah. Have a look. There's a link down below. Or go to the 11 Plus Lifeline page, Google 11 Plus Lifeline, and there's a link at the top for my free marking offer. All right, that's enough for me today. Fantastic to see you, and I look forward to seeing you next week for something different. All right, bye-bye.